Okay, we're going to do a little review for your fun quiz tomorrow. So let's go through some of the answers. What is a force? A push or a pull? Push or pull? Give an example of electric force. From a charge, right? You know, if you have your plus here and your plus here, this one's going to get pushed that way because of the electric force. What is meant by saying an object has electric charge? It means that your protons don't equal your electrons because one's positive and one's negative. Example, how you could charge an object: rub them together for extra electrons. Ta-da! Friction. I don't know, whatever you want to call it. What are the laws of electrical charge? Alright, so for example, opposites attract. Maybe you've heard that before. Like charges repel. Cool. And charge can only be divided. Can only be divided. Right, you can't make charge, you can only separate charge. Separated, whatever. What's an electric field? An area, you know, it's technically volume, but whatever. That makes an electrical force. How do we represent the strength of an area? With arrows. The more arrows, the stronger the field because you're closer. What are the two kinds? Tricky stuff. Positive, negative. What particles of the atom move when an electrical charge is transferred from one atom to another? Electrons. Protons don't ever move. Only the electrons do. What's the law of conservation of charge? Charge. We already talked about this a little bit. Charge can only be separated. Right? So if you want to make charge on this block of metal here, you can push all the positives to that side, all the negatives on that side, and then cut it in half. Then you have two charged pieces, but you didn't create any charge, you just separated the positives and the negatives together. Alright, what's each symbol represent? This guy right here is a switch. This is an open switch, so the light would be off. This is a battery. This is two batteries. Oh, hold on. And this is a light. One of the symbols for a light. And this is a resistor. Right? Resistor could also be like that. But this picture has the European version. Oh well. Okay, which circuits are series and parallel? This is series. We'll do the current in a little bit. This is also series. Don't worry about the switch right now. This is parallel. This is series. Because there's one path. This number 3 here has two paths. You could go through either light bulb. This is series. This is parallel. Okay, which way is the current traveling? Current travels out of positive towards negative, right? So current's going this way, current's going that way, current's going this way, and current's going that way, right? Because there's two paths, so since it's parallel. Current is no current here. Because they're both hooked up to the positive, no dice. Current's going that way, current's going this way, and current's going that way. Cool beans, huh? One more. What is the current? Well, V is equal to I times R. Hopefully you remember that. 120 is equal to I times 40. Divide both sides by 40. You're going to get 3 is equal to I. Now remember, you should have like 3 amps, right? Make sure you put a unit because units are good. Now when you're typing stuff, you should put a space between the number and the unit because that's the convention. Sounds awesome. See you later.